Hello, I am Sarasit and Krittakorn doing our microcontroller project, and now I will explain about our project. So as you can see here, what we have done is we made a countdown timer. Look at me. We made a countdown timer, and so here is our 7-segment display. So let me explain the first button. The first button is a start button to let the countdown go, and the second button is the adding the number. So let's see, adding the number to the countdown, and let's start. We also have a buzzer, which is kind of faulty and very soft. End video. So, hello and greetings to the viewers of this project. This is our microcontroller project. It is a Arduino countdown timer. This group consists of Sarasit and Krittakorn. Let's start. So for our introduction, this project uses an Arduino with an ATmega328 to build a countdown timer that is displayed on a 4-digit 7-segment display. It includes a start-stop button and an increment functionality button. So what have we used? What are our components? So first of all, we have an Arduino Uno with a ATmega328 chip, one 4-digit 7-segment display, 2 push buttons, 1 buzzer, 1 breadboard, and a bunch of jumper wires, and around 4 resistors. So for our circuit description, the display is connected using the 7-segment library, 2 buttons which controls the start-stop button, and another addition feature, a buzzer that indicates the countdown progress. So for our code overview, so the code handles display on the countdown, reading the button states, playing the buzzer sound, and display refresh using the 7-segment library. So the key features in our project is an adjustable countdown, an audible feedback using the buzzer, a real-time display update, and a button control for interaction. So for our hardware setup, and as you can see, if you follow my mouse, this would be our 7-segment display, which is connected to the resistors that's connected to the board. First button right here would be the start button, which a countdown will pop up, and once you press it, it's going to start counting down. And this button, and if you press it, it's going to add to the countdown by 1. So you can kind of delay the countdown. And this right here would be our buzzer. So let us explain the codes line by line. So first of all, we would include the 7-segment library, which we just downloaded. Now for this one is our to choose how long we want each number to display in seconds, the display time, the buzzer frequency we have in 500, and the buzzer duration. We set our default start number to be 10, but you could change that as well. Our end number being at 0. Our buzzer pin connected to pin 0. Our start-stop button pin being connected to 14. Our add button pin being connected to 15. So this one is to track if the countdown is active, the current state of the start-stop button, the previous state of the start-stop button, the current state of the add button, and the previous state of the add button. So let's see our setup. We have the buzzer pin, we have the start-stop button pin, and we have the button pin. So this would be our output, input, input. This is our setup for our 7-segment display to kind of allocate which pin would be which. For this one, we have our true and falses, whether each one will pop up now. And this one is just a config for the 7 segment. Moving on to the next page, we have our method here now. So first of all, we have the read state of the start stop button, which is the digital read, and a check for button press transitions from high to low. And if you can see, if button state equals low and last button state equals high. If counting is not counting, then toggle the counting state, delay 50 milliseconds. And next one, we have for the add button state. Kind of the same thing, but instead this one, we just do a start number plus plus to add the number to the start number. Now for our countdown itself, so for this one, we have if start number is more or equals n number, we can do the countdown. And we have a for loop here, I equals 0, I plus plus, 7 segment number, start number 0, 7 segment refresh display. Start number minus minus because, well, we want to count down. And for each number that it goes down, we have a beep for it. And once it reaches 0, it will display the number 7777, which is what we set it as default as well, and we can change that. We could do 1111, 1234, but this one we just did 7777. And yep, for the last line of code, we want here that if the number is at this, we want it to beep for a long time. So once it reaches 0 and display this number, it's gonna beep, beep like that. So for our conclusion, this project of ours is a simple yet interactive project, which includes a lot of things that we have learned in the classroom, and we implement it a lot. So for our countdown timer, it demonstrates core embedded systems concept, including input handling, display control, and the buzzer output that we have learned in the classroom. Thank you for listening to our project, and goodbye.